Another method of modeling is the classification and regression trees modeling. This is similar to logistic regression modeling in that the dependent variable is binary. It can be a 1 or 0 for true or false or yes or no, but it's a little bit different. Let's take a look. Here we have a set of data and it's graphed, and if we look at it we see that there's an x-axis and that represents an independent variable, and in this particular case our y-axis represents the value of a second independent variable, and our dependent variable is the color of the point for each point graphed. So this is a binary dependent variable because the output can be either blue or red. And that can stand for blue meaning true or red meaning false, or any other kind of binary output in which it can have one of two values. In this case, we don't see any kind of line, kind of linear model. And so the appropriate method to use in this particular case is the CART model. And CART stands for the classification and regression tree. And that's the kind of model that we're going to use. Here you can see that on this graph I've drawn two horizontal line segments and one vertical line segment. This has divided our graph into 4 regions. In this upper left-hand region, the points are all blue, and in this lower left-hand region, the points are primarily red. There's a blue right there. In my upper right-hand region, the points are primarily red, or all red, and in the lower right-hand region, the points are all blue. This horizontal line segment here is y equals 20. And this vertical line segment here is at x equals 20. And then our last line segment, which is a horizontal line segment here, is at y equals, that looks like about 24. So we're going to use these line segments to help us build our tree. Let's take our model and shrink it up and move it up. Now let's construct our tree by looking at the vertical line y equals 20. And we want to ask the question, is x less than 20? Because if it is, we're looking at this region that has 2 subregions, which is to the left of the line x equals 20. So we ask the question, is x less than 20? This is either true or false. If it's true, then we're looking at the region to the left of the line x equals 20, and we need to ask another question. And that question is y less than 20? And this is true or false. If it's true that y is also less than 20, then we're looking at this lower left-hand region, and our output or dependent variable is more likely to be red. If it's false, then our output is more likely to be blue. If we start back at the top and we say that x is not less than 20, it is false, then we have to ask the question if y is less than 24, because we're in this region to the right of the line, x equals 20, and we have to decide if we're in the top of this region or the bottom. So we ask the question, is y less than 24? If it's true, then we're below the line y equals 24 and above the line x equals 20, and we're in this lower right-hand region, and our output is more likely to be blue. If it's false, then we're in this upper right-hand region and our output is more likely to be red. Here we have completed creating our classification and regression tree. This tree structure gives us the model to do our predicting.